All right, so let's get started on 5-2. 5-2 is multiplying two fractions. So you should have your companion books with you. If you don't, please pause this video so you can go get them. All right, so here's our launch.
I'll wait. I've heard of minibuses before, but that was ridiculous.
All right, so your favorite museum is 3/4 miles from your home. You walk half of the way there and ride a bus half of the way there. Tell how far you walk, include a picture in your response. So here's a copy of the companion page. So this is page, doesn't say what page it is on my version. So you should know multiplying two fractions. So tell how far you walk, include a picture. So go ahead and pause the video. If you finish quickly, do a reflect question. How can you find 1/2 of a whole number like 1? Do you do something different to find 1/2 of a fraction like 3/4? Explain. All right, so pause the video, try this out on your own, see what numbers you come up with. All right, so hopefully we got something that looks a little bit like this. So if here's your house, here's the museum. You walk half the way, so you can break up the distance from their house to museum to 3 = 1/4 mile parts, because 3 times 1/4 is 3/4. So this is Monty's way. Whole number times numerator gets that. We leave the denominator the same, so 3 times 1 is 3, 4 stays with 4. 1/2 of 1/4 is 1/8. So if you take 1/4 and cut it in half, you get 1/8, because 1/8 plus 1/8 is 2/8, which is, we can simplify down to 1/4. If a half of each part is 1/8 mile, multiply the number of parts 3 times 1/8 to find how far you walk. So 3 times 1/8 equals 3/8 miles. On a number line, 3/8 is halfway to 3/4, right? If here's 3/4, halfway in between is the 3/4 mark, and then this would also be 3/8, excuse me. Here's 3/8, the other is 3/8. So the answer checks out, okay? So basically, if you put 0 here and 3/4 here, exactly in the middle will be 3/8, okay? That reflect question, you can find half of a whole number and half of a fraction the same way. For example, you divide each into two parts, all right? Dividing into two parts and multiplying by a half are exactly the same thing, and we'll talk about that another day. So basically, 3/4 miles from your home, if you walk halfway and ride the bus halfway, tell how far you walk. Well, if they're both halves, you can do 3/4 times 1/2. So I'll open up a new Google. So this is the same thing we talked about at the end of the last class. In this lesson, we'll go through this more formally, but if you wanted to try this old method that we learned on Friday on this, we could do 3/4 times 1/2. So numerator times numerator, 3 times 1 is 3. And then our denominator times denominator, 4 times 2 is 8, which is also 3/8, which is the exact same thing as what we got for here. Okay, so let's go ahead and do part 1. You can use a model to multiply two fractions. Here is how to model the product. So remember, product is the answer to a multiplication problem. So 3/4 times 2/3. So first step, we're going to show 2/3. So I have one box, I divide into 3 equal slices. So that 2 of them shaded in out of 3, 2 out of 3 are shaded in. Now we're going to do 3/4 going horizontally. So same box, 1, 2, 3, 4, and 3 of the 4 are shaded in. But notice that these 3, so if here's line 1, here's line 2, here's line 3, here's line 4, these 3 are empty. And why is that? Because the 2/3 that we got in the first one here, the 2/3 left this third column always empty. So it always has to be blank. We're looking for the intersection where the two overlap. So to find the product, 3/4 times 2/3, the whole square now has 12 equal parts. The purple part shows 3/4 of 2/3. So here's 2/3 that we originally had, and I divide that 2/3 up into 4 equal parts, and 3/4 of that I shaded in. So I have 1, 2, 3, 4, 5, 6 out of 12 total, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3/4 times 2/3 is 6 out of the total 12, which I can reduce as 1 over 2. All right, so each square below represents one whole. Drag the multiplication equations to the correct model. So take a second, just look at these. Which ones do we think goes with each one? So take a second and just look and think. Okay, so for this first one, I'm dividing it, so up and down, I have 1/2, 1/2. So I divided this into sets of 1/2, and then horizontally, I divide it up into halves and halves again, and then what's being shaded in, what's the intersection? Well, I have 1 out of 4 total squares, because there's 1, 2, 3, 4 total squares, so my answer should be 1/4. So I divided one side into halves, the other side into halves, and my answer is 1/4. Well, half, half, 1/4, that should be that, okay? Same thing for this one. Here's one, I divide into 3 slices, 3 long bars, and I do the same thing horizontally, 1 bar, 2 bar, 3 bar. So I have 1/3, so I have thirds and thirds, and now I see I have 2 horizontal and 1, so I have 1 this going up and down, I have 1 here, and then going up and down I have 1 here, but then horizontally I only have 1 of them shaded in. So I have a 2, so if I theoretically shaded in all of this 2/3, and then I theoretically shaded in this whole slice here, that'd be a 1/3. So 2/3 and a 1/3, and if I look at where they intersect, well, that'd be 2/3 times 1/3, and I see that there's 9 total squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 2 out of the 9 shaded in. So this guy should go with this picture, because 1/3, here's, if I divide it up horizontally, 1/3, 1/3, 1/3, and 1 of them shaded in. Same thing vertically, but the 2 of them are shaded in. So I have 2/9, so 1/3 times 2/3 is 2/9. Process of elimination, this guy has to go here. But we can also see this is divided up into thirds, one long row, another long row, another long row. So 3 going up and down, and then 1, 2, 3, 4, 5 going left and right. So that's fifths. And then I have 2 columns being shaded in, so that would be my 2. And then I have 4 filled in out of the fifths, so 4/5, 2/3. 4 times 2 is 8, 5 times 3 is 15, and look at that, 8 out of the 15 total squares are shaded in, so 4/5 times 2/3 is 8/15. Excellent. Okay, in your companion book, you got this guy, which square represents one whole, which multiplication matches the model. So go ahead, pause the video. Here are some answer choices. Is it 1, is it 2, is it 3, or is it 1 and 2? So pause the video, see what you come up with. All right, so our correct answer is 3 only, because if you have this guy being a 1 and this guy being a 1, well, there's divided up into thirds, left to right, and then also up and down. So both my denominators should be 3 denominators. So 3, 3, 3, 3, 3, 3. So all of them could be it. Let's take it a step further. I have 2 columns shaded in, so I should have a 2 in the numerator somewhere. Well, I have a 2 here, 2 here, 2 here, 2 here, 2 here. So they all still can work. But looking up and down at the rows, I have 2 shaded in. This one shaded in. This row is shaded in, and this row is shaded in. So I should have another 2/3. So now this guy is out of possibilities because he has a 1/3, so he can't possibly be right. 2/3 works here, 2/3, 2/3. So we're down between 2 and 3. So how do you know which one's right? Well, it's the answer. This one says 4/6, or this one says 4/9. So 1, 2, 3, 4 are shaded in. So I should have a numerator of 4, which I do in both of them. But how many total boxes do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. This guy says we only have 6, so 2 has to be wrong. Correct answer, 3 only. All right. In your companion book, you also get this. If you multiply 2 fractions together that are both less than 1, can the product ever be greater than 1? So take a second, pause the video. What do you think? All right. So no, if both fractions are less than 1, when you multiply, you're finding part of a part. If you find the part of a part, could that ever be bigger than 1 whole? No, it always has to be less than 1. This is why when you multiply two decimals together, it's always smaller than 1. When you multiply two fractions together, it's always less than 1 because you're finding a piece of a piece. If you have a slice of pie and you cut that slice of pie into more slices, would you ever get more than 1 whole pie? Well, no, you don't even have 1 whole pie to start off with. So it always has to be less than 1. Okay? Key concept.
Ready for some more general rules? These you can always use when multiplying fractions. Check it out.
All right. So the examples in part 1 illustrate a general rule that you can always use to multiply fractions. 1/3 times 2/3, 2/9. We already know numerator times numerator, numerator. Denominator times denominator, denominator. Same thing. 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. 5 times 3 is 15. So the general rule in words, when multiplying two fractions, multiply the fractions together to find the numerator. Multiply the fractions numerators to find the numerator of the product. So numerator times numerator gives me numerator. Multiply the fractions denominators to find the denominator. All right, so 3 times 3 is 9. Same thing. If necessary, write the product in simplest form. So we don't have any here that would need to be simplified, but let's say, for example, you had 4/8, we would need to pull a 2 out of the numerator and a 2 out of the denominator. So 4 divided by 2 gives me 2. 8 divided by 2 gives me 4. Still need to simplify, so pull a 2 out of the 2, you get 1. Pull a 2 out of a 4, you get 2. So 4 divided by 2 is 2. 2 divided by 1 is 2. So 4/8 I would need to simplify as 1/2. So you always simplify your answer, okay? General rule, hold on. You can use this general rule for any two fractions, a over b and c over d. So a over b times c over d is a times c in the numerator over b times d in the denominator. Same thing. Numerator times numerator gives me my product as a numerator. Denominator times denominator gives me my product in the denominator. Okay? Part 2. Drag each pair of factors to make their product. So we're looking for two numbers that multiply together to get the product. So 4 nines times 1/5. Well, 4 times 1 is 4. So I'm looking for something up here with a 4 in the numerator. 9 times 5 is 45. So I'm looking for 4 over 45, which is right there. All right, 3/4 times 5/8. Well, 3 times 5 is 15. 4 times 8 is 32. So 15 over 32. All right, 5/11 times 2/7. 5 times 2 is 10. 11 times 7 is 77. All right, next, 5 nines times 7 eighths. 5 times 7 is 35. 9 times 8 is 72. All right, 1 times 3 is 3. 8 times 2 is 16. So 3 over 16. And then 5 6 times 5 6. Well, 5 times 5 is 25. 6 times 6 is 36. Check. Excellent. Okay. In your companion book, you got this. Find the product of 2/5 times 4/5. I'm not going to give you answer choices. You don't need them. Take 30 seconds. What do you think it is? So we get 8 over 25 because 2 times 4 is 8. 5 times 5 is 25. All right. I ran out of time on this, so we're going to have to switch over to the third video, and that'll go over part 3 and the closing check.